Hello friends, I have an updated video on how to make sense of current data and things that are going on with COVID. And as a quick review of the last video on April 23rd, I published a detailed walkthrough of how we do have reliable data available to us that can accurately help us estimate the number of people that are asymptomatic carriers of COVID. So we can get an idea of how prevalent is it in the public. And based on that math, we found that as of the last week of April, the COVID was practically eradicated in our region of Central Oregon, that it was near zero or at least less than 10 carriers that were asymptomatic around town, and it was dropping quite fast. Also concluded that it would take until July to start to see, some sort of action again based on tourism being introduced into the town. And we would need to take a look at it in July to determine the difference between sparks that fizzle out or a new outbreak. Now, the video had content that pretty much disagreed with everything that was officially reported by the hospital's data analyst contractor. At the time in April, there was a lot of talk about this surge in May that's going to come and how there's no way we could know any different. Well, time went by, mid-May came, and the hospital had no sick people. That comes as no surprise when the math and the data said at the end of April that there were no carriers left. But it was a big surprise to the hospital. They were geared up for all sorts of surge plans of being able to redirect patients to off-site, off-campus hospital beds and having tents in the parking lot and everything. Instead, they found they had no customers and their revenue was having trouble. Fast forward to July, we're in our current week here. May and June proved to be surge-free, but also we're looking at this concern. What does July bring? Are we seeing sparks fizzling out, or how do we make sense of this? So that's the goal of this video here. The question we want to answer is, what level of concern should I have? Should I be focused on just being a good citizen and respectful of others and take reasonable precautions? Or should I be concerned specifically this week about, just not wanting to catch COVID this week? Right? So what we want is like a green light, red light, just a simple signal. How should I be going about life right now? So the goal here is to avoid having COVID at the same time as a surge with a bunch of other people, where I show up at the hospital wanting some care and they're turning people away or having to set up tents or something. This type of question involves predicting the future, because if a person were to contract COVID today, and if that person were in the 1 out of 10 people that get it, that would benefit from having some sort of care given to them, that person would be looking for that care in about 2 weeks. So the question we're asking is, will the hospital be able to support the number of people that are seeking care in about 15 days? So these are the two numbers we're looking for. What's the predicted need of new patients in 15 days? And what's the predicted capacity of care in 15 days? Now, the capacity of care, we can start with, well, what's the hospital capacity today? That's a number that's available. It would be different in 15 days, but I think today's number of available beds is a pretty reasonable number. There are reasons to think it'd be a little higher or a little less in the future. In a surge scenario, it would make sense that there would be a few more beds available in 15 days, because if things really were ramping up, they might cancel elective surgeries or start discharging patients a little quicker for different reasons. But as a starting point, just using today's available capacity for the hospital as a number is pretty reasonable. So how do we know the predicted need of patients in the next 15 days? Well, if it is a surge, then it's going to follow a surge pattern, which increases at an exponential rate. So with a few numbers, we can figure out the predicted, need of patients in about 2 weeks. So the numbers we need is the number of people in the hospital, actively seeking care for COVID today. And then we take that number, we need to have a length of time in which it quadruples. This is an exponential term. So we need to know, when was it 1/4 of what it is today? And the number of days between that it went from being a fourth to what it is now, that's a period of time, that's a quadrupling time. So that number, we need that. I listed a couple special cases here. The main one is if the last day that had a quarter or less is 0, we may need to look at other data. So if, say, there were 0 people in the hospital for COVID and the next day there were 6, one day isn't the answer there. If there were 0 people and then 1, 2, that kind of thing, a fourth of 2 isn't easy to find. We're too early on the curve in that scenario. And so that's where the other video is able to use proportional relevant data to figure that out. But if we're in a state where we have enough points of information and enough people seeking care in a hospital that we can get this number of days, here's how we use it. There's an exponential formula here that is a bit, no fun to read. So I went ahead and did the math. All right, if the quadrupling rate is these numbers of days, then this is the potential worst case scenario number of new patients that the hospital will need to take care of around the time that I may be needing care if I get this and will be seeking care in a couple weeks. The quick point to point out here is, because it's exponential, a difference in a small number is a bigger difference than a bigger number. So if we look at like 6 days and 10 days, it's a difference between 31 times and 7 times. That's kind of a big difference. We compare that to 16 days and 20 days. The difference is 2.7 to 1.8. That's not as much of a difference. So it matters a lot at the beginning. Well, let's see how this plays out with 2 examples. The first example here would be a red light example. This is the data that we were looking at in the middle of March that was concerning. Let's look at what we had here. So number of people under care was 3. We had just a couple people in the hospital. But the days to quadruple was pretty maxed out at 6. You look up here, that is, the kind of the largest multiplier on the chart. So to figure out the need of what the hospital should take care of in only a couple weeks, we multiply 3 by that 31 multiplier, and we get 93. All right. So can the hospital handle 93 people in a short period of time? Now, at the time in March, the current capacity was 2 empty beds. In fact, some reports were coming from the local hospital that they were full. Not of COVID patients, just out of normal operating procedure. We could take that current capacity and figure out some sort of predicted capacity in 15 days. I would say we predict the capacity is less than 93. This is an example of a red light scenario. Let's compare that to data that we may be seeing more recently. Okay, let's look at how a green light example might play out. Okay, when we look at the news and the current people under care is 8. Okay, that's a lot more than 3. In the red light example, maybe there's 8, maybe there's more. But if the days to quadruple is a bigger number, that means it's quadrupling slower. We have a different multiplier. All right, so let's take that 12 number, look up here, 4.7. So you go through, look at let's say 8 people currently, multiplier 4.7. Worst case, we may need 38 patients, to have care given in just a couple weeks. Let's compare that to the current capacity available. Again, I'll mention this as an example. I'm not saying that these are numbers specifically for today. The numbers are going to change every day. But what I do know is, according to Wikipedia, there's over 200 beds in our local hospital. I also know that if you consider the broader region of the county, there are 2 other campuses of this hospital with other beds available. So out of those hundreds of beds potentially available, let's put a number in here of 50 beds available to walk through this example. So if there's currently that many beds available, how many beds do we predict will be available in 15 days? Well, probably 50, maybe a handful more, but certainly more than 38. Okay, this is just a greater than, less than problem at this point. So green light, red light. Between these 2 examples, this shows how you could be less concerned about 8 people under care than 3 people under care. And it's all about watching the statistics day to day and getting an idea of how fast, in an exponential sense, is this thing spreading. So where do we get this data, the number under care and the current capacity? It shows up in news articles at times, but I don't know. Are we all supposed to just call the local hospital and demand this information? Boy, it'd be nice if a local news service was made aware of this and they were able to track it for us. They could put some sort of surge-o-meter on their homepage. It'd be a very helpful thing. But at least you know what data to keep an eye out for and what it means. Given our extra hospital capacity lately, I would say we were in a green light today, in this area. That's something that can change in a matter of days. So it's good to continue those habits that prevent spreading things. And if I were to look a little further ahead of what to expect in the coming months or whatever, I have to just think about other outbreaks that have happened in recent history, even some of those being coronavirus-based strains of outbreaks. They tend to be contagious during the winter respiratory flu season, the November to March time, and to have a break in the middle. They also tend to have 2 seasons worth that make the history books, but the 3rd season doesn't make the history books, even without any vaccine. So that's kind of curious. So while it is something we can keep monitoring, I'll give my I would not be surprised if scenario here for the next year. We could continue to have cases throughout the summer, but it's likely they'll fizzle out as fast as they start. So the hospital can keep up. That's the hope there. Then we'll be back to some fun headlines come November to March timeframe. I put in here that it would be more cases next winter than all the cases we got this winter, primarily because of just the anomalies of testing. The initial tests were rationed, and the general expectation, or what was common in March, for example, was that for every 1 person that was given a test that was confirmed, there were probably 9 people that just didn't have a test that were highly suspect. So if you take the idea that there will be more tests being done next winter, then we could have the same type of outbreak, the same type of winter, and have many more cases officially on the record book. So it will seem confusing because at the same time, we might have like 5 times the cases next year compared to this year. We'll have maybe the same amount of hospitalizations or people seeking doctor's care. And at the same time, we'll have it being even more survivable. And, why would I say that? It's because we're going to know a lot more about this bug, a lot more understanding of what it does and how to treat it. When you think about it, November is 4 months from now. And we've only had this pandemic for 4 months. So there's as much time even remaining before November comes as this whole thing's been going on. And then I threw in this last one here. The fall 2021 vaccine will be wildly successful. Well, that's because it's even a little bit in question if there's going to be a third season, even without a vaccine. So, yeah, we'll get a vaccine in there and people will get it. And you add that to the mix, and we're pretty sure we're not going to have a third season. Well, that's my update. Thanks, guys, and take care.